piece of metal and you shine a light at it, electrons fly off, and that's normal for metals. Light will release electrons. So these are little doots are electrons. And that has a name, which we won't worry about. But the electrons fly off, and he noticed if light was a wave, that when the light waves hit the metal to push the electrons out, it's not like it burns a hole in the electrons. There's just a few that leave the metal, and they have to be detected.
Just the thing for that.
Thank you.
Yeah.
All right, appreciate it. All right. When the electrons fly off, and they have to be detected with very sensitive instruments, but he noticed that if it was a wave, once the light hit the metal, it should take a few seconds for this to happen because the energy in the wave has to build up. Several crests would have to hit. But when the light hits there, the electrons fly out immediately. So that does not jive with the idea that light is a wave, but rather that light is, what else could it be? It's a beam of particles. And what are the particles? Well, we call them photons. Have you heard of that word? Those are little energy bundles. So to make a long story short, some people hold that light is a wave and some hold that it is a particle. And in some instances it acts like a wave, like here with our holy screens, and here it acts like a particle. So we call that the wave particle, write this down, wave particle duality of light. I love that name. It sounds so smart. So, write down that phrase, wave particle duality of light, which is a fancy way of saying light is a wave. In some instances, it acts like a particle in other instances. So which is it? Is it Einstein came up with some formulas that work as if it's a particle, and other people have come up with formulas that work in certain circumstances when it's a wave. So which is it? Well, right now, we just say there's a duality, but it goes a little further than that. So hang on to your socks, because what about electrons? Weren't we taught that they were particles? They have a mass. We've actually had a mass of electrons in some of our equations. So the question doesn't seem to be a question at all. Are electrons particles? Well, believe it or not, there are situations where they act like waves. And guess what? There is a wave-particle duality of electrons. What about baseballs? Seems like they're a pretty big particle, but there are situations where baseballs act like waves. So there is a wave-particle duality of baseballs as well. And what about you? What about the table, the wall, the paper, the tree, anything in the universe? There are certain ways that it acts like a particles, and that's what we're used to. But there are ways, down in your physics life, you will discover them. We can't really touch them right now, where they act like waves. So there is wave-particle duality of everything. So, on that philosophical note, we'll end that mod, all right? All right, there's no new formulas today. I apologize. I guess there was. We did the lightning and thunder, but that came from 3rd grade. So, all right, pretty lame. That's it for today, and we're gonna. Did they hear? We're gonna have a quiz on Friday on this mod. We'll review a little bit tomorrow, and then we'll start the next mod as well. So we'll have a duality tomorrow. Goodbye.